Hello everyone and welcome back to the tutorials and CiliaQ. If you remember, we've been through CiliaQ Preparator and CiliaQ Editor, and now it's time to explore CiliaQ and get to know how it works and what we can do with it. As a general point, if you remember, I mentioned in the general introductory tutorials that CiliaQ can reconstruct the ciliary object based on the image, which is processed with CiliaQ Preparator and Editor, and then quantifies cilia and visualize the results. Now, before any explanation, let's go back to Fiji and open up CiliaQ. Then we can check all the options together. So when you have your Fiji open, you can open CiliaQ plugin by clicking on plugins. And on CiliaQ, you can choose CiliaQ, and the first dialog will pop up for you. Beginning from the first option, you see process. Here you have three options like what we had in the CiliaQ Preparator. You can see active image in Fiji, which you can process only the currently open image, which is basically the most front image that you have. You also have the option to open the multitask manager and upload multiple images by choosing multiple images option, or you can choose all images open in Fiji and then process all the images that are currently open in Fiji. As a second option, here we have the calibration settings. And here in these boxes, you can see different numbers which indicate the calibration settings of your images. So if you already know that your images have the correct calibration settings, you basically don't need to do anything else. But if you have doubts about these settings, then check the option for manually calibrate image, and then you should enter the correct settings in these boxes here. Well, I can show you how you can get your calibration settings basically. Let's close this for a second and open an image. Just as an example, I will open this image. And now that you have your image open, you can go under Image and Properties, and you can see the correct calibration settings here. For example, if you check the pixel width, you can see that it's about 0.12 microns in the real world. And now if we go back to the CiliaQ, you can use the correct settings for your image and just click on it and input your correct settings here. So basically choosing this option only depends on if you know that your images are calibrated correctly or not. Next, we have detection settings. And here we have two options in the preferences. We have manually enter preferences, and by choosing this, you should choose the preferences manually in the next dialog that we'll see later, or you can choose to load preferences from another metadata file that you have produced before. So basically, if you have done the CiliaQ analysis for an image and the settings are correct, and you want to use the same settings for the other images, then you can use the metadata file that is produced with your first analysis and simply load it and continue the analysis for the rest of your data set. Then we go to the output settings here. And here you have multiple options. These options allow you to retrieve more output files or to add a data suffix to the output file names. With checking the first option, save data in output file names, you can avoid overwriting of your files. So if you have an existing result file and you want to try another set of settings for the same image, then considering this option will help you avoid overwriting of the result files, and then you will be able to actually compare the different settings that you have tried by comparing the results for the same cilium that has been detected and processed with the different settings. Next box is for saving the result image for each individual cilium. And it is necessary to check this option if you want to look at individual cilia in time-lapse images, because the common output file just gives an average over time for each cilium, whereas the individual cilia files in the folder give the results for individual time steps. But if you do not use time-lapse images, the common output file provides all information for each cilium separately, and there is no need to activate this checkbox for standard applications. Then we also have 3D visualizations for each individual cilium that you can see here, and it's basically help you save 3D visualizations for each cilium in the same folder as result images for each of them. However, I must mention that 3D visualization can slow down your analysis pipeline because their generation is basically time consuming. So if you're analyzing many cilia and you want to have 3D visualization for each of them, it'll take longer time. And the last option of the output settings, which you can see here, is save 3D visualizations for whole image. If you check this option, then CiliaQ will produce the 3D visualization of the whole stack. And later, after we do CiliaQ for an image together, I will show you the output files that are produced by it. At the end of this dialog, we have output number format. And to choose which option works for you better, you should know that if you want to do the analysis in Excel, you should adapt the settings to how your Excel software defines numbers, whether it uses a dot or a comma as a separator, because that makes it easier for you to later import data from CiliaQ output files in Excel. So now that we went through all the options here, we can just click OK and go to the next dialog. Here we have intensity quantifications, and you should set here whether you want to quantify any intensity values or cilia coverage in additional channels of the multi-channel image. Then you can also check the basal stain, which is this box, and you can change the settings of the channels here basically afterward. So if you open a text file, which is the output of your CiliaQ preparator and contains the information on the channels, you can see which channel, for example, is your segmented channel. And also if you want to, if you know that you have a basal stain in a channel, then you can easily just change this according to the channel number that you have your basal stain in. But as an example here, if we go with the default settings, you can see that in the first channel, which is the segmented channel, as you can see here, you have the cilia labeling, and this channel serves for reconstructing the cilia. The second channel quantifies for intensities and refers to in the output files as intensity A. And the third channel quantifies for intensities and refers to in the output files as intensity B. And the fourth channel here is the channel that I have my basal stain in. So the next option that we have is increased range for connecting cilia. And basically, by choosing this option, you can determine which mode is used for connecting adjacent voxels to form a cilium object. Well, maybe I can explain this better with an example. So if you check the box in the CiliaQ settings, then CiliaQ will connect a voxel, like this white square, if we imagine it as one voxel. It will connect this voxel to all the direct adjacent voxels, which are the blue ones, and all the diagonally adjacent voxels, which are the orangish squares in this picture. And so all of these will be connected to our voxel to form a cilium object. And if you do not check this option, then only directly adjacent voxels will be connected and not the diagonally adjacent voxels. And however, this increase range function is helpful when the image features a bad signal to noise ratio, or when cilia are incompletely labeled and contain small gaps in labeling, but it can also feature the disadvantage that noise voxels can be added to cilium objects and can cause errors for the length detection. For example, in these images from left, you can see an imaginary image of the cilia in the segmented channel. Now, if you choose the increase range function, you can see all the voxels that are not even a part of the cilium are also selected as part of the cilium object. But when you have not chosen the increase range function, then the ciliary object has been selected correctly. Coming back to our CiliaQ plugin, you can also use a noise filtering option that is shown here by minimum cilium size. And it helps you to set a threshold for detecting the cilium. So for example, here, if you choose the parameter of 10, then all the objects that have less voxels than 10 will not be detected as a cilium. By using the next option, which is shown by additionally exclude, and you can see that you have, again, multiple options here, you can actually remove the incomplete objects at the image border. So with this option, you can exclude the objects that do not lie completely within the image field of view. So objects that touch any of the borders can be excluded. So for example, if you have 2D images, then by choosing cilia touching X or Y borders, then you will exclude the cilia that are touching the X and Y borders in your 2D images. And if you have 3D images, then you can choose the option for X, Y, or Z borders. Now, as I told you before, CiliaQ can analyze intensities in additional channels specified by A and B that we went through them before. And usually CiliaQ determines parameters like the average ciliary intensities in these channels. However, you might want to study overlap of the cilia with another structure. And so you can use the mask of cilia with another mask in another channel. If you would have segmented another channel other than your ciliary channel, then you can use CiliaQ to determine the overlap of the ciliary mask with the mask in that channel. Under these circumstances, CiliaQ allows you to also filter the other segmented channel with a minimum size filter, as well as determining how objects are detected, whether also diagonally pixels are linked or just vertically and horizontally ones. So if you don't provide segmented intensity channels, leave the value that you see here under minimum size of intensity regions to 1 and as it is, basically. The next option, determine skeleton-based results, that you can see here, is used for skeletonization of cilia. So the skeleton that is determined is used to determine the length of the cilia and intensity profiles along the central track, which is basically the skeleton of your cilia. You use this option to avoid that you have too many side branches, and you should always use a Gauss filter where you must adjust the sigma if you get too many side branches or length estimations do not work properly for your data. But if you want to know more actually about the sigma optimization, You might need to check our CiliaQ wiki, where you can also find a post on the sigma settings and side branches in the skeleton. You also have tangent and curvature calculations here, and it basically calculates and output the tangent vector and the local curvature for each ciliary point. But the parameters for the tangent vector and curvature are relevant only for specific applications in the physics community. And so if you apply CiliaQ for standard application, you can leave the settings as the default values that we have here. So if we consider that these settings are correct according to what we need for our image, and considering that the image that I want to analyze now has the same channel settings as the order I have here, as the default settings exactly, then by clicking OK, I can move to the next dialog, where I can upload the image or images that I want to be analyzed with CiliaQ. So you just need to choose the select file individually. And now you can actually go to the destination that you have your images saved in and choose either the CQP TIFF files or CQP ED TIFF files that you can see here. So either the output file from the CiliaQ preparator or CiliaQ editor. I would choose the CQP ED file that is the output of the CiliaQ editor. And by clicking open, then you can easily start processing. And just to mention again, the timing of your analysis depends on the options that you have chosen before in your CiliaQ in the first dialog. For example, if you have chosen the 3D visualization, then it would take a longer time. But let's wait for the analysis to be done, and then we can go through the output files together. Okay, so now my analysis is done, and like the other plugins in CiliaQ package, the outputs from the CiliaQ plugin is also stored in the same file that you have uploaded your images from. So if I open my folder that I had my images in, you can see that the outputs are all saved with CQ ending. First, let's check the CQ text file. And this is actually a tab delimited text file that you can use as your metadata file. And if you remember at the beginning of this tutorial, I told you that you can either choose the manual option for inputting your settings, or you can just upload this metadata file that you will have. So if you have tried one of your images with the settings and the settings are working for your images, you can then just upload this metadata file and you can easily use this instead of the manual option. We also have this CQRP file, and it is actually a copy of the input image after the noise filtering of the reconstructed channel. So if you open this and zoom in, you can see that this image also contains labels of the detected cilia objects, and each cilia will have a specific ID that you have in the text file, which allows you to easily relate analysis results from the text file to the specific cilia in the image. We also have the CQSKL file. And if you open this image and zoom in again, you can see that this image shows the detected skeleton that are labeled with the analysis IDs of the respected cilium object. Last but not least, we have the CQS text file, which is also a tab delimited text file that contains only the results line from the text file, with the CQ ending that we saw before, but without the label captions. So if you copy these details into an Excel file, you can see the information more clearly. So actually, let's do that together. The only thing that you need to do is to select everything, copy them, and I like to paste them from the second row of my Excel sheet, because then I can copy these other information from the CQ text file and paste them here, and you can see which column represent what parameter actually here. So in this way, you can see all the IDs and you can extract the parameters for each cilium from different columns. All right, with this, we come to the end of this general introduction of our CiliaQ plugin package. We will come back, of course, with more specific topics regarding the settings for your image analysis. But until then, if you have any questions regarding the settings, we will be more than happy to answer them in our GitHub page. Until then, goodbye.